Well, welcome everybody from wherever you are, whether it's a good morning or good afternoon. Glad to have you with us. And I'm honored to have quite a panel with us going to join us today. So to get started, this is part of our continuing series on the grid. And as some of you may be aware, we did a session earlier in the year in February on software with the grid, and this session, we wanted to focus primarily on resilience. So let's get stuck in. For those of you who know us, I'm Andre, and I'm joined by Alex, who's our specialist in the grid and the storage. And we're part of Pantokrator. So if we looked at some of the previous sessions we've done, I mentioned the grid earlier, but we also do a lot in storage, in car charging, in thermal heat, and AI. These are all available either on YouTube or even on our website. So for those of you who are new to today's session, I just wanted to make you aware of that. So if we jump straight into the grid, and as I mentioned before, we looked a lot at software previously in terms of distribution. Today we wanted to focus on resilience, which is very important to not overlook, because while we're upgrading the grid, we've got to make sure that it works, and we've got to make sure that it doesn't fall over. And we've seen some instances in the last couple of years where it has. But we believe there's actually a very interesting business proposition for that. In later webinars, we will look at how we can build out the grid faster, more efficiently, get more out of it, and also look at decentralized solutions. So there's a lot more to cover as we go forward over the next year. But today we'll focus primarily on resilience. So what does that mean from a kind of a macro sense? The underlying theme here, supporting everything about the grid, is that the load factor is going to increase by a factor of 3x over the next 25 years. And that's driven by just growth, but also the proliferation of EVs, by industrial heat, by AI, and we're converting everything going electric. So the grid has got a lot to contend with. And as you'll also see, the grid in most of the developed countries is actually quite old. And on average, it's over 40 years old. And it's analog, it's not digital. So it needs a lot of help and a lot of change brought about to it. When we talk about resilience, we think really about just keeping the lights on, making sure things don't fall over, or almost like insurance. But as we dug into this, we found actually, as you start to focus on resiliency, there's some really interesting ROIs that come out of this. And partially looking at OpEx savings, a good third of that could be done, as well as finding you could put more throughput through the actual capacity that we currently have, and that's up to about 40%. So there's clearly good revenue potential as well as cost savings in the technologies that we are centered around resilience. So to take us kind of forward in terms of the growth over the next couple of years and some of the implications, I wanted to invite Alex to share some comments.
Thank you very much. So I guess to lay the scene, the way we're seeing it is that energy is expected to rapidly grow in terms of tripling by 2050. And as Andre mentioned, there's a couple of themes behind that. There's the electrification of heat, increased uptake in EVs, and as everyone knows, but the role of data centers pushing this demand along. So what does this mean for the grid? It means that already today we're spending about $1 billion per year, or $1 billion per day, and that's expected to more than double by 2030 alone. But in terms of the actual existing grid, well, it already needs 150 billion a year of support. And we see a big role of resilience technologies to actually enable this, both through maintenance and monitoring, as well as overall digitalization, to really allow it to keep pace with the scope of the energy transition. Now, developed economies actually are a bit more susceptible to this as well. A lot of their assets are over 20 years old, in fact. But from what we've seen, actually a lot of the developed economies on average, their grid is 40 years old. So what does this mean? It means that their assets were fundamentally designed for a different era. They didn't have to worry about such an increased role of renewables in the grid and all the challenges of adapting that we now have to face. So as a result, we need technologies that can allow the grid to keep pace and catch up. So if we look into a bit more of what this means, there's been a huge effort in tackling the energy transition through scaling renewables. But one of the challenges that we're now facing is that there's a lot of interconnection queues of getting these renewables through about 3 terawatts worth. So what we really need is a resilient grid that can actually allow this stream of renewables through. And similarly on the demand side, we're seeing with data center queues, you can wait up to a decade to be connected to the grid in the UK and Ireland. So it's a challenge on both the supply and the demand side. But critically, what we actually need is not a capex heavy approach, but rather a way to make existing assets work today, not in 5 years. So if we look at what can resiliency actually offer, it's not a single bespoke solution that actually can work all the way across a grid, from generation to consumers. If you're looking on the generation side, it can be drones when it comes to maintenance monitoring solutions. Transmission and distribution, it's actually upgrading the lines with embedded digital monitoring solutions. So think of things like dynamic line rating monitoring alongside proactive maintenance, so the ability to do proactive vegetation management, wildfire detection, so you can actually keep the lines going, but also boosting the capacity going through them. But underpinning all of this is digitization for digital grids. So the idea of upgrading the existing assets for a virtual grid so you can more intelligently use your assets today. So what we've included here is a bit of a snapshot of the players actually delivering these solutions, highlighting our wonderful panelists who will be speaking a bit more later today. A key point to emphasize though is it's not like these players are only doing a single solution, that they're actually offering versatile platforms that are able to offer multiple different solutions because their clients, utilities and CNI aren't facing just one single solution, it's a multifaceted problem. So players are actually able to offer a differentiated approach, tackling multiple problems other ones are succeeding today. So from an investor point of view, why should they be interested? Our panelists will also be presenting a bit more on themselves later, but the way that we also see it is there's a huge market that already needs help today, and we're seeing wide-scale adoption by utilities and CNI. But the question is why? Well, ultimately, it's not out of charity, it's because it's an actual value today. So in terms we're seeing increased revenue because you're pumping more capacity through the lines, and we're also seeing a reduction in OpEx through more efficient operations. So in closing, some of our key takeaways, there's a real need to act today. As we've seen in Iberia, it took less than half a minute for the grid to go down. So ultimately, whilst we like to think that the grid is this resilient structure, a lot more support is needed to actually keep it going and to meet the challenges that we face with the energy transition. There's a big role when it comes to technology too, digitizing assets so that we can actually make the best use of what we already have today, as well as the role of AI where we have so much data that can already be leveraged to boost operations. Finally, there's the aspect of the market. Utilities will remain the incumbent solution, but there's an increased role of CNI. In fact, some of our panelists are actually focusing on CNI as their initial market entry, whilst looking at utilities in parallel. But regardless of their approach, there's a need for a versatile platform, the ability to target multiple solutions and not be funneled with a single approach. That way that they're able to deal with many different problems for their customers in a scalable fashion.
Excellent. Thank you, Alex. So I'd like to introduce our panel, which is Eddie from Energy Impact Partners, Eran from Prisma, Rahul from Vi Technologies, and Manuel from Enline. Maybe if I could start with you, Eddie, to get a few minutes on yourself and Energy Impact Partners.
Hi, yeah, hi everyone. So I'm Eddie from Energy Impact Partners on our sort of research and innovation team. So helping develop our theses on all things the demand side of the energy transition. And so yeah, I can give you a bit of a background to EIP. So we're founded in 2015. We've grown now to about 4.5 billion AUM, investing in almost 150 of the world's leading energy technology companies, all the way from early stage deep tech through to venture growth, late stage buyouts and credit. Very, very recently we just closed our latest flagship fund 3 at around $1.5 billion, which is really great. So looking forward to deploying that into a lot of the world's leading companies in this space. So we are backed by over 80 of the world's leading corporates with an interest in the energy transition. This is global utilities, built environment players, including data center operators and more traditional real estate players, but also a lot of the supply chain energy OEMs, like GE, Vernova, Carrier, etc. So yeah, have a really great insight through our partners onto the core problems that are holding back the energy transition. Yeah, fun fact on the right-hand side there, in our EIP coalition, we have over 2.5 million miles of transmission and distribution network. So when we think about grid resiliency, we like to think we can get some good insights there to really understand those problems. And so, yeah, this is our kind of overview of our portfolio. And we like to think that, with these partners that we have in our EIP ecosystem, we can help these technologies and our portfolio companies scale. So today, I think between our sort of portfolio companies and our LPs, we've facilitated around 1,000 contracts, bringing in $3.6 billion worth of revenue for our portfolio companies, just selling into our LP base. So really have flexed that muscle there in terms of helping out our portfolio companies and helping scale these technologies. And, you'll see a lot of the logos on the page. Some might be familiar to you. Across the energy transition where resiliency is very important. Recent highlight, Urban was recently acquired by Itron, which is really exciting. Recent investment in Vi and also Asset Cool on the resilience side. So yeah, it's been a super exciting time for us. That's I guess a brief overview to EIP.
Excellent, Eddie. Thank you very much. May I now turn to Eran from Prisma?
Thank you very much. Eran Inbar, I'm the CEO and founder of Prisma Photonics. And what we would like to show is a new approach for transmission line monitoring. We started our journey late 2017, and we're focusing on new approach for transmission line monitoring. What does it mean? In order to monitor today, you need to deploy physical sensors along the grid, which we would like to find an approach that it's highly scalable, that we can do hundreds, thousands, tens of thousands of miles easily. So we're not deploying anything. What we're using pre-existing fiber optics that are along most of the transmission line today, and we use them as sensors. So practically we can monitor tens of miles, but same effort for thousands of miles. And what we can do with this scalable technology, we can go to the next slide and see part of the use cases. Part of it is enhancing capacity, which is under the title today, Dynamic Line Rating, how to enhance the capacity of the grid by 30, 40%. But it's more than this, it's also covering resiliency related issues from extreme weather condition, wildfire detection, extreme wind, galloping, icing, and lightning strike, and also electrical related event, anything from short circuit to partial discharge to flashover and so on. And we can finish with three, just showing the use cases. Next slide is just showing the story that the system can tell, a mechanical damage that causes a short circuit, that eventually cause a reconnection of the grid. Everything can be monitored, covered with precise localization and in real time. The story of a wildfire. We can not only monitor and alert real fire, but see the propagation along the grid and do a precise localization of such a significant event like a wildfire close to the grid. And the last slide, we can see, extreme events like this is, just one of the recent case study that we show. Even a car hitting a tower structure, real-time event with precise localization. That just three examples of new approach to scalable transmission line monitoring for capacity and resiliency related event. Thank you.
Excellent, Eran. And I gather your system is picking up more and more data with every month that goes by. So I'm sure we'll talk about that as we get into the discussion. So may I invite Manuel, if you could tell us what you've been up to at Enline and introduce yourself.
Hi, good morning. I hope you can hear me well. I'm Portuguese. I'm the co-founder and CEO of Enline. I spent more than 20 years in the energy industry, And we saw this big opportunity of using software and multi-physics approach to bring a very unique solution where by recreating the assets using existing information from engineering and from plans and from single line diagrams and for existing sensors, we can create these replicas. We call the digital twins in a new way that we like to call sensorless, but sensor friendly in a way that we use existing hardware and existing information. And we are now recently part of ABB. They just invested in our company, just so you know, is now official. Basically, this principle is quite, let's say, as I said, multi-physics, a lot of mathematics, a lot of physics combined in with AI. Of course, we use AI every day more and more, and I will show you something new that we are developing. And this is seems like magic, but by using data and existing information from the projects in the way we do it, we can assure a very, very high precision, let's say accuracy. And we have been compared with sensors and local, let's say in situ measurements and always above 95, 98% accuracy when compared with local measurements. And this is unique. There are no other company in the world able to make it like we do. And the fantastic is that we can deliver thousands of kilometers per day, anywhere, anytime in the world, and by just making the process as I explained it. I'm currently in Peru physically. I just came to visit some customers, but we are deploying projects in Australia, in India, in Canada, in US, in Brazil. And this is the let's say, I like to call it a revolution because something that was hardware dependent, now you can do it in a very, very fast, very, very, very competitive way by a small portion of the investment by using hardware and unlocking the flexibility, unlocking visibility, unlocking the knowledge that we need from the grids. Because grids, they still big black boxes, no visibility, no knowledge, and we are just operating like just in the beginning. The knowledge that we have are in the substations, and this is not good. We cannot live with this situation. And this is the we are deploying these solutions all over the cycle, let's say from generation, transmission, distribution, consumption. We are specialists in grids, but also in critical let's say elements of the grid from generation to consumption, substations, transformers, etc. And by using this multi-physics and multiple layers injection of data from weather and natural risk, capacity, infrastructure, generation and load, storage flexibility, combined using our digital twin tech, we have this full visibility, full monitoring, making it dynamically, increasing capacity, efficiency, reliability, safety, visibility in real time, in simulation if it's necessary for simulation, but also predictively. And then we can see everything. And the AI agents is something that we are working a lot because the AI agent is now the virtual agent, is the twin of our customer, listening the customer need and just giving all the information in a very synthetic way, ready for decision making. And then make it simple. I just to give you a view, Optimax is a solution that we have to reduce losses in big generation plants. We can reduce losses up to 40%, something that was impossible to do up to now. And now we are deploying this all over the world, increasing by millions the generation of these customers. And this was just an example of one solution. And the most important is the team. Our team is the best. We have the best engineers, people from the industry. We have former ministers, people from let's say the deep technical development, AI, power systems, and these are the ones making this possible. And thanks for your time. And let's continue.
Manuel, brilliant. That's really conclusive. Thank you. And now wrapping up, Rahul, tell us a little bit about VI Technologies.
Thank you. Hello, I'm Rahul Chaturvedi. I'm the founder and CEO of VI Technologies. So what we found, we started the company in 2017, basically focused on predicting failures in mechanical rotating equipment. But over time during COVID, we found that the same solution can be implemented on transformers. We have this tiny little sensor which does triaxial vibration and temperature measurement that is literally a lick and stick kind of sensor where you epoxy it to the outside of transformers. And the reason we focused specifically on transformers was, as Alex mentioned a little while ago, that the grid is very old, and 70% of our transformers are over 25 years of age, and 25% are well beyond their useful design life. So with that type of transformer condition, as well as the troubles of having supply chain issues, at least in the United States, 80% of our transformers are imported. And we have serious supply chain issues where tier one transformer manufacturers are tapped out for 4 years, tier two are tapped out. So what we need to do is make the best of what we already have, which is in a sense, increase the asset life of the transformers that do exist. And how you do it is by doing a stitch in time kind of solution. So our solution is, to the best of my knowledge, the only solution that actually uses leading indicators of failure to predict the failure in transformers versus all the traditional methods that use lagging indicators of failure, the standard being the dissolved gas analysis in the oil industry. So we have non-invasive, continuous, and autonomous prediction of failure in transformers, which then can move the current industry, utilities, and CNIs from the schedule-based methods that have been used so far to condition-based. So our goal right now, we're actually as of yesterday, we're over 700 transformers under management. This slide is about a week old. We want to reach 15,000 transformers, transmission level, generation level transformers, and hopefully double that many distribution level transformers by 2028. The idea is to essentially predict these solutions well within a very short time window, so that less than 30 days, you should be able to see not only what's going on with your transformer, specific types of failure modes, but also how that failure mode is tracking relative to the way you're loading your transformer and managing the transformer transients, load, and weather conditions, etc. And we do that essentially, if you think of us, the standard way, as I said, the dissolved gas analysis, think of it as a blood test of transformers. You can only do it once a year or so. And think of us as a continuous 12 lead EKG of the transformer. And what we have done is we have essentially created in the cloud an AI-based virtual radiologist, if you will, that can read these signatures and tell you exactly what's happening inside the transformer on a real-time basis. Our accuracy right now is 99.95%. In fact, I'm happy to inform that we've been in the market since 2022. And so far, we have not had a single transformer under our management lost. So, I mean, that we love to brag about that, and hopefully that stays that way for a long, long time. So right now, the idea is to have multiple of these epoxy to the transformer, and then wirelessly collect the data with this has 10-year battery life, and then have our virtual radiologist, if you will, in the cloud predicting failures. So our deployments are currently global, mostly focused in the United States, but we have other deployments in other nations as well. The idea is to demonstrate that we have solutions implemented in the cold weather of Mongolia all the way to the heat of Phoenix, and the solution works just as well in any condition, any kind of weather, any kind of outcome. So that so far, we have been able to prevent and protect and extend the life of these assets for the utilities and our other partners. Thank you.
That's excellent, Rahul. Thank you. And that wraps up a good introduction of our panel, which I believe it represents a really good cross-section of kind of the key points in the value chain on what is going on in resilience. So with that in mind, I'd like to maybe kick off a discussion, and maybe if we start off with, what's the state of the market right now, and why do we need to act now? And maybe we start with Eran. Maybe give us a little kind of overview of, how do you see the major challenges facing the grid now, and why do we need to act now? And then maybe also, Rahul, if you had some thoughts on that.
Thank you, Andre. I think that, one can claim that the grid didn't change a lot in the last 50 years, and we can be cynical and say that the last big change was the battle between Edison and Tesla about AC versus DC grid. But I think that a lot happened in the last few years, and I think it's mainly regarding capacity demands. Data center being built in few years and consuming power like a small cities. That's something that we cannot compensate on the rate that we're building new transmission line. EV cars, a house with 2 EV cars suddenly double the power consumption, or renewable energies. Suddenly energy is generated not when you need it, but rather when you have sun and wind. All of them, enormous issues to the grid operator. And you mentioned the grid is aging, 50 years old in average, so big issues today. And I think that those are the challenges that we're facing, that are growing significantly in the last decade or so. And we, as companies in this field, need to try and help our customer utility to solve it. And I think that capacity is a major issue. And I think that, we will build new transmission line, but it will take 20, 30, 40 years. Meanwhile, we need to extract the maximum capacity safely from the grid. And I think that that's all about dynamic line rating, how we can use data in order to get much more without increasing the risk from the. And here we would like to add something. I think that when we are looking at it, we need to do it not just smartly with data, but in a scalable way, not just to do a successful pilot, but how to build a solution that can easily be scaled over thousands of kilometers. And that's part of the challenges that they were in the past, but right now they are, we're just close to facing the wall in this aspect. And that's part of the challenges that we're facing: capacity and resiliency due to aging.
And Rahul?
Yeah, actually, good point. I actually see it as 3 different buckets. The aging infrastructure, clearly, I would think that is 50% of the problem, that we have an aging infrastructure. The grid was designed in the 60s and 70s, at least the US grid here, and it's getting very long in the tooth. So that's one piece. And the second piece, let's say, 30% of the problem is demand growth. Of course, we're seeing that, 2023 in the US, the demand grew by 0.2%, 24, 1%. This year, they're saying 2%. Next year onwards, they're saying it's going to be continuously 3% for all the foreseeable future. So that's a massive load growth. But then there's a third bucket that comes to mind, which is the renewable integration plus grid stability in itself has become a massive issue. And the reason I say that is because if you look at just the stability side, the load itself is increasing, but the load's nature is changing. So what you're seeing is that fundamentally, these GPUs coming in and EV charging coming in, they're creating massive yo-yos and concentration of loads. So the demand is not steady. It's not just simply growing steadily. It's actually jumping up and down a lot. And then on the renewable side, what's happening is that, we get into this whole idea of, inverters into transformers. We're seeing a lot of power quality issues that are coming, harmonic distortion and load variation, etc., as well as there is a congestion issue. Because when you have these renewable energy sources coming in, you start getting a demand-supply imbalance. And then lastly, I would say, the grid was, in my mind, it was designed to be it was brilliantly designed, by the way, but it was a one-way street. Now with the DERs, distributed energy resources, we are trying to take that one-way street and convert that into a two-way street. Now, my daughter went to school in Boston, and if you've ever driven downtown Boston, you can just imagine the impossibility of converting those one-way streets to two-way streets. But we're doing it. And then, we're not doing half bad a job. But those are the key issues that come to my mind in terms of what the challenges are. And so, why do we need to change? It's a perfect storm. I mean, that's where we are. We are in the middle of a perfect storm. Our habits are based on the 0.1, 0.2% growth rate. Our planning, our processes are based on that. But the need is entirely different now.
Yeah. And it's not all about averages. It's kind of, you get various spikes in various areas. So it creates those pressures. There are times where you can fall over.
That's right.
But let me turn to Eddie just for a second. I mean, Eddie, we often hear about, well, gee, renewable energy generation, that's down like 90+% in terms of cost. Energy storage, here again, that's way down in cost. My electricity bills are just going up and up. So what gives? So, and you kind of think the culprit here is the grid, isn't it?
Yeah, I mean, it's something we've been tracking a lot. I mean, renewables are the cheapest form of generation, but it seems like the pressure is shifting from generation to delivery in a way. And Rahul mentioned it. It's about there's congestion, but there's also these like power quality issues. And so if you look at, I guess, the breakdown of an electricity bill, I'm just drawing on some examples in the UK. I mean, the wholesale price itself is, I don't know, about 35-40% of the overall bill, and then you've got all of the extra network costs, policy costs on top of that just add to it, and it's these like delivery costs that are starting to drive up bills. And even though the generation is getting cheaper, the problem is that the cheapest kilowatt hour is like stranded if we can't move it. And so that's why we need to prioritize a lot of the technologies we've been talking about here. The dynamic line rating, grid enhancing technologies, queue management, etc. So at least that's the way we've been seeing it.
Yeah, and maybe just on that point, we see more about extreme weather conditions and fires and and so on. And it also maybe include on this, Rahul and Eran kind of thoughts on this. But how much is the extreme weather conditions just adding to these expense or increased expense in grid?
So there's obviously the piece of electrification, and then there is the extreme weather conditions. So I would actually, let's say, just start with a simple thing, which is the heat, excess heat generated due to extreme weather conditions. So what happens is when you have a piece of equipment, there is some inefficiency that, as we know from high school physics, energy can neither be created nor destroyed. It just converts forms. So that releases as heat. When it releases that heat, the idea is the external weather is going to, the wind flow, and that will actually remove the heat away. But as the outside temperatures increase, that heat has nowhere to go. So now what you have to do is you have to use pumps and fans and compressors to extract that heat, thereby creating more heat. So now you've created this vicious cycle of constantly increasing heat that actually is going to push these equipment to their limits, and therefore reduce the overall life. And that's just heat. And I'm not even started talking about, the geothermal induction currents and the hurricanes and the tornadoes, etc. So you can see how that hurts. And then I'll also actually throw in that electrification piece, which is that electrification itself is forcing us to tackle some very complex issues on the network side and also on the value chain side. Because, with that increase in electrification, as I mentioned earlier, the demand is lumpy. It's not an evenly distributed demand. It's lumpy. It is less predictable. It's very dynamic. And then on the value chain side, you have these concentration of critical minerals and, some rare earth metals in certain geographies and even other components that are creating shortages, etc., along the way.
I would add also that when we're speaking, for example, about wildfire, as you mentioned, we need to divide in between extreme weather conditions that caused wildfire to utility caused wildfire, because grid is aging. We're putting the grid under increased stress, and failure happened, and utility caused wildfire is a liability issue that utility cannot bear. It's like a huge issue, and we expected the utility to be able to deal with it, to prevent it, or if it's happened, to give, a sufficient notice about it. We also expect that third-party extreme weather condition, the grid will be resilient to those, even though we're trying to extract capacity, so the grid is under stronger and stronger stress aspects. That's, for example, why we're looking, when we Prisma looking at it, we're saying capacity and resilience are quite tied together. Eventually, we call it, dynamic line rating for resiliency. You need to give the utility the complete platform, because, part of extracting the capacity would, put them in facing more problems as extreme weather conditions are more frequent. So you need to look at the platform approach that utility should get the capability to extract more capacity safely, but still get the alert or the prevention capabilities to deal with those expected extreme weather conditions. It's part of the new needs of utilities under these growing stresses.
Yeah.
I'd throw
And I
in
guess,
reliability
Eran,
too.
sorry, go ahead, Rahul.
Yeah, no, I'd throw in reliability too. I mean, you have asset level reliability because these extreme conditions are reducing the asset life. I mean, as talking about transformers, is these conditions, the actual health of the asset, the transformer asset, and you can go to switchgear, etc., is so much a function of the weather. It's the external heat that reduces the life the most, not the load, not any other variation, but that's what impacts. So that reliability of the underlying asset is so important, and extreme weather conditions, the more we have, the worse that makes the asset life.
Yeah. No, I was just going to add that when you look at, peak times, let's say 6, 7 in the evening, everyone's on, and that's where you typically get, the stress of the system. Whereas, but if you look at the average utilization, it's probably below 50% in many cases on the medium and high voltage. So there's quite a bit of, I guess it's really about flexibility and traffic direction, if you will, which I guess it's not something easy to crack, but it's there. But maybe let's turn over to Alex. I know you had a couple of questions, particularly on AI.
That's good. So I guess, Manuel, to kick things off, how do you see of how AI can modernize the grid?
Well, thank you very much. That's a good question. I think AI is becoming part of our lives and will be everywhere. And let's say AI combined with existing technologies, grid enhancing technologies and others will help us to see what will happen, have capacity of optimizing simulations of new projects. For example, we have many AI applications for grid modernization, grid planning, for example, improving grid capacity from the project design, but also for existing grids. Another example is the seating and permitting. AI will help us to simulate and make different, let's say, reviews of the everything by bringing from the human decision for super computational power. You can imagine how fast can it be. And then I see the biggest impact in terms of grid operation, grid reliability, predicting failures, simulating loads, making risk assessments, and also grid resilience, detection and diagnosis of in few seconds, diagnosing faults, detecting how to solve it, make it in a very, very fast way instead of in a passive way like we do today. Just some examples. No, I don't want to extend too much.
No, it makes a lot of sense. Well, I guess also especially about speedy decision part. I mean, the irony is with, the Iberian blackout, someone might have just gone to the toilet. By the time they're gone, we're back, then the grid is completely off. So the ability to actually handle those kind of split-second crises, I think, is really important.
Yeah, just one last sentence.
Sure.
The question, I like to see it in, as an engineer, I am in boxes. No, one
Mhm.
box is the grid planning. The second is the seating and permitting. The third is operations and reliability, and the last is the resilience. And then all combined, we will have a much safer and much optimized grid system, let's say.
Makes sense. I guess going one step further, and Eddie, also curious of your thoughts on this. So you were previously mentioning about digital twins and digitized grid. I guess what benefits do you see from a deeper level? I mean, in terms of from all the work that you've been doing of digital twins for the grid, what do you see as the key benefits?
Yeah, I mean, like almost addressing those buckets that Manuel mentioned or Rahul mentioned earlier around, visibility, control, integration of renewables, flexibility, resilience. It's all those things that I think the digitalized grid can unlock. And so, I mean, just to maybe, I think some examples that spring to mind, particularly one of our portfolio companies, EV Energy, and the way they've been like shifting EV charging to off-peak times requires a lot of digitalization, both from like a price signal point of view, but also from like a control point of view. And there was one trial they did in California, shifting 98% of their charging to off-peak times, which is just incredible. And like without a digitized grid, you cannot be doing that. And it goes broader all the way up from, that's at the customer level through to the distribution and transmission level. I think like, with the like even at the like cybersecurity level as well is another thing we've been looking at. Without a digitized grid, you cannot build the resilience from like a cybersecurity level, which again brings resilience in another form we haven't quite touched on yet. The sort of digital resiliency. So yeah, really like tons of different ways we can look at it. Whether it's just like pure visibility and control, to drive that efficiency, all the way through to like the customer side of it as well. I think there was one aspect that I was really interested in as well around the like integration of renewables. I think someone mentioned it earlier. Well, last I checked, I think in 2024 it was 1.2 billion pounds worth of like renewable generation was curtailed in Great Britain. And I mean, with a better, like digitalized grid and better integration of renewables, we can just avoid tons of these costs and help like push ourselves towards the transition that we're all trying to get to. But seems like there's these like key unlocks through digitization that can just help us integrate all of this and balance load better. So yeah, that's how I see it.
Makes a lot of sense. And I guess, Manuel, in your case, have you found that there's any benefits that customers have been surprised to find in terms of when you've started discussions, gone through a pilot, but then, once the pilot's completed, have there been benefits that, people didn't appreciate until they've gone through the pilot?
Yeah. Sorry, I don't know if I understood completely the question.
Right,
Can you repeat?
right. When it comes to the benefits of a digitized grid, when you've been dealing with customers, have there been unexpected
Okay.
benefits out there? It's only
Of
after
course.
you've actually gone through that you
Okay, okay.
appreciate the
Sorry,
full
sorry.
story.
No, is a new world, let's say. He's becoming from the darkness
Yeah.
to the illuminism, let's say. Is a completely new world. If you have visibility, if you have flexibility, if you can see the future, if you can simulate wherever you want by using a system that is sensorless, fast, very competitive, make it is, let's say, I can give some examples like DLR is some of the, let's say, of the top solutions now. We can just implement DLR anywhere in the planet, and we can make with one engineer, one inline engineer, we can build 2,000 kilometers per day. Just one. If you want 10,000 per day, I can also deliver. And then you start having DLR in a very, very fast way, and you can see how much capacity you have possible to unlock. Easily 50% is the something that we can secure anywhere in the planet, but some cases can go even more. This is one. Second, optimization of projects in simulations. We are working in projects, especially in Latin America and in Australia, where we can reduce capex of projects by making these AI simulations with power systems. We can reduce capex of projects up to 20%. You have an idea how much money we are talking about? Second, about data centers integration. They are just looking to find the best place to put the data center. And they have this big issue of the curtailment, and the grids are not basically able to give them the energy they need. We just create the grid and we tell them, okay, these are the spots you need to put. You can imagine how much you can help them to optimize this process where they have no capacity to identify, and we are doing that remotely anywhere in the planet. The same with renewable. In Brazil, we are working with the biggest wind farms and solar farms, just helping them to give visibility how to solve curtailment, and then talk with the national operator, that is ONS, and give the flexibility to make these dynamic line rating projects, and helping them to make the communication easier, because then you need to talk with the regulator. The last example, just to finish, about the Optimax. A solution, again, sensorless, remote, anywhere in the planet, and we are working with customers like Total Energies, increasing revenues from existing wind farms offshore, for example, and we can just in few projects we increased more than 3 million euros per year just reducing losses. Knowledge of the grid, dynamic parameters for the active and reactive power control, and as a new solution based in the sensorless digital twin, and we are unlocking billions or even trillions of energy sales that they are limited because you have losses, thermal losses, electrical losses in the cables. And this is the magic of our solutions. And this, I gave just some examples. I don't want to extend too much, but it's a new era. It's a big revolution that we are bringing to the market. And it's very, very exciting times for us, but also for the energy and grids markets. But we need to be fast. Time is counting, and we don't have so much time to make it.
No, that is very fascinating. Well, it's also, as Aaron was saying earlier, there's a real need to have a scalable solution. So, like with your approach, if it's a case of, oh, you don't have to fly out an engineer to get to a specific site, and then, the heavy manual approach instead, this is actually very versatile. So that makes a lot of sense. And actually, Aaron, in that perspective, because both Manuel and yourself do a lot of work with utilities. Right. How do you see the ability, as you were touching on, Manuel, to integrate renewables and reduce the congestion in terms of when you've worked with utilities, what's been the best approach to actually help address the congestion challenge?
Yeah, I think that when we are a startup working with utility, we think, okay, utility is conservative, risk averse, we are a startup, we are agile, we are innovative, so we will do a pilot, we will present our technology, and then the utility will take it and will deploy it over 10,000 miles. And I think that our role is much further than showing the pilot, but really building a deployment that would be, I would like to say, seamless to deploy in a scalable way. Because eventually to take a successful pilot and deploy it over 10,000 miles, it's very, very complicated for the utility. And the idea is to build a solution that would be easily deployed. That's why, we are monitoring through existing asset, through the fiber optics, because we don't want the utility to start to deploy sensor. I think that furthermore, we're speaking about a lot of problems today that utilities are facing, new problems. And we can say, okay, I will solve you dynamic line rating, another one wildfire, another one short circuit detection, and you will do integration with 10 different startups. I think that's also a big burden on the utility. Someone need to build a platform, That's why when we're coming, we're saying we would like to solve you, the utility, the capacity and resiliency related event, because it's even hard for the utility to do 10 different integration for 10 different startups. So I think that our job is not finishing in showing the innovation and showing how the pilot is working, but really, really helping the utility to do the big, the complicated task, the deployment over scale, and you should design for scale from the beginning. And I think that's maybe our main task, that our solution will be scalable if you would like, as Manuel said, to see it scale over, 10,000, 100,000 of miles globally.
Yeah.
Makes a lot of sense. Otherwise, there'd be a nightmare of, oh, what if you have to do this bespoke situation with one client and then it's another? Or especially, I mean, if you're dealing with some of these big utilities, if you had 10 individual projects with 10 different contact points, just being able to streamline that process, saying, look, I've got a platform, I can do all of this. Let's negotiate it in one go.
Yeah, I think just to add like a investor perspective on this, like when we've been looking at startups in this space, selling to utilities, it's really hard. We see a lot of companies getting stuck in like pilot hell. It's really hard to push beyond that. Utilities are known for having a really hard and long sales cycle. But I think it's a really important point you make about designing for scalability right from the offset, because trying to break out of those pilots and as you say, expand over thousands of miles is really difficult. But I think, now kind of seems like the time is right. We've been speaking to a lot of our utility partners. I think I mentioned earlier, we have like a few million miles worth of transmission and distribution in our network. And it's like, it seems like that pain threshold is now starting to be crossed. Whereas before, a lot of these solutions were a nice to have, but now it's seeming like it's a need to have. And so, yeah, it's really important, I think, as was mentioned, to design with that scalability from the offset and drive it like that. So a really nice point.
Yeah, and Eddie, that was going to be kind of a further question I had, which is there's a lot of issues that the grid are facing. There's a lot of technologies, and prioritizing it is kind of a challenge. Do you feel that in the kind of world of the technologies that we're talking here, they're top of the mind for the utilities, because we're starting to see more failures, and as a result, they're sort of going to the top of the agenda in terms of let's test it, let's take it seriously, i.e., so the ability to commercialize. You say it's not a nice to have, and do you see that kind of filtering through? But what is the main weakness that is being attacked there?
Yeah, I mean, so I feel like a lot of the time it's about like the value proposition that you bring and the specific problem that you're trying to address for the utility. And yeah, as I said, it seems like we're in this sort of perfect storm where integration of DERs, renewables, affordability pressures, wildfire risk, etc. is starting to like force that pain threshold to be crossed. But there's many different of those value propositions that you can target, whether it's reducing outages, helping speed up connection queues, helping increase like utilization on grid, so you're selling more electrons. And so I really think like making sure you're very crystal clear on like which one of those weaknesses you're targeting is super important, because there are just like a multitude of layers at which you can go in at. So yeah, I mean, many different angles, for sure.
Yeah, and you mentioned earlier, the cost of curtailment. We totally agree. We see that actually increasing by 20-30% a year in many countries. I mean, you mentioned the UK. Germany's, I think, at about 5 billion now. And Manuel, you mentioned Latin America. That's a big issue, certainly in Brazil. But if I could come back to Rahul, I mean, I remember in previous conversations, Rahul, we talked about the complacency or the comfort factor we've got, and so we've got enough transformers. We're fine. And actually, I think listening to you, we're not. We might have a crisis in the world of just transformers. Maybe tell us a little bit about that.
Actually, the transformer situation has gotten worse and worse, and like I said, so there are multiple areas that are being hit. As I described earlier, the transformers are being hit from both sides: the load side, all those GPU variations, etc., and the EV charging and the growth, and then on the supply side, now you have all this renewable integration happening that is also hitting the transformers. The demand, I think Wood Mackenzie reported that it's grown, will be 30% short of transformers this year. I mean, that's a lot. And that's largely because of the 119 or 120% increase from 2019 to now in demand, but the supply is restricted. And because the supply is restricted and because the supply is concentrated in certain areas, it just makes it harder for us to procure them. Some of the lead, I mean, simple service entrance, 2.5 mega, MVA transformer is now running like 50 weeks. And the transmission side, if you look at some of the bespoke transformers, that's 120 weeks or more. So we're talking about a real issue here. And on top of that, what we have is that, to me, it's become a national security issue because we don't manufacture here enough in the United States. We import 80% of them. And we also are running out of capacity to repair. So while we're taking these transformers offline, we have, we're only limited capacity to repair. So that particular asset type that is absolutely critical to the existence of our grid is under a huge amount of pressure, but the demand keeps growing and growing and growing. And so there is this tendency to hoard and, people will buy and store the transformers that they have. So I think, long story short, the idea is to make the existing asset perform better and be able to move load around as needed so that you can extend the life of each asset separately and the collective overall. And that's what we're trying to achieve here.
Yeah. I would have thought, Manuel, with given the visibility you've got, just listening to you, that you could perhaps stave off quite a few crises in the world of transformers by simulating kind of, if you were able increase flexibility in this part of the grid, by putting more storage there, you'd reduce the pressure on transformers that have only got X amount of years to live, because I think what we got is a crisis coming. And the question is how you can stave that off for enough time to actually backfill some of the capacity that you're going to need.
Yeah, transformers they are just a piece of the puzzle. I agree, and the main question was how we see the utilities changing. I always like to see the other side. The most of these big utilities companies, they were public companies. They are risk averse. They always think, why should I take risk if I get the same salary at the end of the month? And then this is a loop. Do not matter if it's in Peru or in Portugal or in US, they are all risk averse. I think that the pressure will be so big, and we will start seeing episodes like Portugal and Spain blackout. We will start seeing this happening a little bit around the world, or during a storm or during something. This will be the new normal. Will take time, but I think that there is no way back. Digitalization, that what we bring to the equation, combined and working together with companies like VIA, like Prisma, we are all let's say modular, and we fit in a space. There are space for everyone. What I see is that our contribution from Enline will be the very fast deployment, flexibility, freedom to simulation, freedom to make customized solutions to fit in the need, but bringing something that I don't see so much in the market is that I see many companies talking about AI, but then I don't see power systems knowledge. Like they talk about AI like very good mathematicians, statistics, but then if you miss the lag of the power systems, I don't know, it seems very weak. And what we bring is that combined with this very fast digital twin implementation, giving all this visibility. But it's so good, it's so unique that they take time to understand. That's my contribution. Thank you.
So, can I just add a little bit? A very good point here. So the solution here is not one single solution. I kind of see this as asset up thing that we're doing predictively and telling you what the transformer is behaving like, and that data that is very valuable because it's real time, continuous. And then the top down system level down approach that Enline is taking. So it's a combination of the two that'll solve the problem. It's not any one element, because see, you cannot look system down if you have bad data coming up. And just going asset up is not sufficient because you need to understand the system. So it's the combination of the two that'll actually get us where we need to be.
Yeah. No, I was going to mention that, the utility sector has been sort of taken for granted, or it's been there for like, many, many years. And, it's a very steady, stable industry. Now it's been thrust into the foreground as being one that's got to change overnight. It's of strategic importance, right? As you've got, you're electrifying economies, you're getting into AI. The race for AI is about energy, not so much money. So in a way, you've got this industry that everyone took for granted as just being just there, right? And now it's got to jump into the 21st century, and so many different people from different angles have to work on it, because you've got to upgrade it and fix it and make sure it doesn't fall over and function in the process. So it means that, I guess, looking at careers today, getting into a utility, it's something that's got real equity value and probably, a much more proactive part or a front room player in any economy. I just wondered if there's any thoughts on that, whether that's a bit too radical or.
No, I agree. I mean, at least in Europe, the numbers we've been looking at, like load has been sort of, at least the electricity demand has been declining, well, flat if not declining over the last like few decades. And now suddenly we're at a point where like we're expecting a lot of load growth, and obviously that puts a lot of pressure on utilities, but also makes them the spotlight. And so I see, yeah, I agree with your take here. I think there's definitely a lot of uncertainty as to like how like large that low growth is and exactly when it will come, and also how different technologies might impact that. But I think it's definitely thrust utilities into the limelight, and is making them a very exciting place to work, and also I think challenging a lot of the maybe more like old school conceptualizations of them, and making them more innovators, and hopefully pushing them to be these front runners that do take on innovative solutions going forward, and drive change.
Yeah, I just wondered, are you all, Manuel and Eran and Rahul, are you seeing a similar thing, or?
I think that, we're speaking about capacity and load as a big problem of the utilities. And I would like to say it's not a problem of the utility. It's problems of countries and governments and regulator. And it's definitely very exciting that you need to, you can help in such a huge problem. It's not just the utility trying to do some kind of fine tuning or be more efficient. It's like a real problem that, the utility can solve it, but it's a huge problem. It's a problem that, everything we're doing become electrified, and we're facing the wall, and definitely, walking in such a, under such challenges, that's exciting. That's for
Yeah,
us, for utilities, for everyone that in this domain today.
Yeah, it's like it's a problem, but it's a huge opportunity, right? Like if
yes.
you're a utility, you want to be selling more power. And so if there are solutions out there that can help facilitate that, obviously you need to make sure all the regulatory incentives are aligned, and so on. But yeah, this is a massive opportunity, rather than just like a problem in front of us, which is
Yeah.
which is exciting.
I
Actually,
agree, but just one contribution. I think that like in aviation, no, the big developments came after big crashes, no, and I think here will be the same. I think it's very linked with the human beings. We need something really impacting, and this means some new blackouts, and especially in most developed countries, like it happened in Europe, will happen more and more. And I agree. the policymakers and regulators, they need to create this enabling of that innovation companies, innovation, they can really come and opening big tenders and big, let's say, facilitate that this can be really implemented. What we saw is a lot of pilots, like they are testing, getting the knowledge, but we need to be faster. That's all from my side.
It almost feels like we're entering a whole new era. I mean, I'd like to call it the era of intelligence, where, you know, AI will be penetrating pretty much every aspect of our human existence. And just like the industrial era was powered by steam engine, this era is going to be powered by electricity. So we have a combination of that computational capability and the drive to just insert the machine learning and artificial intelligence into different things, but feeding that whole process would have to be on the electrification electric side. And that's where a lot of new careers will develop, because new opportunities pop up in areas when the growth is high. When you're growing slowly, you know, it's fine. But once you start that hit that hockey stick, now you have to get very, very creative. And I see that as a huge opportunity for, you know, kids entering new careers now.
Yeah, for sure. Maybe just to touch on that. So I used to work at the energy regulator in Great Britain called Ofgem, and I caught up with a few of my friends that worked in the innovation team there recently. And they're saying right now is just like the craziest time, because so many people are proposing new things. You know, new startups applying to grant-funded programs, doing crazy, exciting stuff. And so, yeah, as you say, it's time for innovation. There'll be lots of new careers, lots of new technologies, hopefully being deployed. So, yeah, very exciting time.
Yeah, and you know, I'm starting to see a change of the thinking in the utilities themselves. I mean, they were in these white towers, right? But you know, with guys that are operating in the thermal energy storage, the electric one, where they only need to buy power, let's say, for like 4 or 5 hours of the day, they need huge amounts. And the sort of inhibiting factor there is getting grid access. But when they show to the grid, actually, look, by buying power at any 5 hours of the day you want, i.e. your troughs, give us grid access. So they're starting to be offered very preferential terms for that grid access, which until now has been quite a, you know, take it or leave it. But the grid is saying, actually, by having use these storage units sort of pegged down to us, that flexibility is actually going to allow us to actually have a lot more throughput on our network, right? Because as I think, Eddie, you said, you know, they're in the business of selling energy, right, or power. They want to do more of it. So I think there is a sort of a kind of a view that we're part of a system rather than we're just the guys in our ivory tower selling power.
Yeah, for sure. We have a portfolio company in the US called Enchanted Rock, who are doing, you know, similar lines, where they're trying to help data centers get online faster by using their like reciprocating engines to enable flexible interconnection agreements. So kind of saying, you know, we can curtail for, I don't know, a couple hours a year to alleviate those grid constraints at peak times. But in doing so, help data centers get online faster. And so it's where can you find those win-wins that are enabled by technology, and, you know, flex the regulatory sort of incentives to make those happen. And so, yeah, completely agree that, you know, with these challenges come many opportunities for innovation.
Yeah, no, absolutely.
Utilities are, you know, return on asset companies. So the asset becomes the fundamental important. You need to put the right assets in place, the right time, the right way, connect them in the proper, you know, plan them correctly, so that you can sell that energy that you want to sell. And so the focus has to be, you know, if assets become the weakest link in the chain, and you know they're not available, or you can't, the lead times are long, or the quality is not so good, then suddenly you have all the challenges, and those are also additional challenges, and therefore opportunities that we need to address.
Yeah, no, absolutely. So I don't know, maybe we're coming up a little bit against our time, and I just wondered, we've uncovered a lot of different subjects, and maybe I would just sort of, in closing, maybe go around the table and just sort of leave it to each of you to kind of share some parting thoughts. You know, they could be based around, what do we see happening, or what we'd like to see happen over the next couple of years? What do we need to see more of? And I know, Eddie, you've got a 30,000-foot view because you sit right on top of the whole thing. So maybe people start with you.
Yeah, for sure. So I would say it feels like we are at a moment where, as I alluded to, like that pain threshold is being crossed, and these technologies that may have been around for a while are, starting to become need to haves rather than nice to haves. And I guess where you can layer on like extra innovation and extra technology to really solve those pain points. And as we said as well, like design for scale so that you don't get stuck in pilot hell. I think is going to be really important, and making sure that your value propositions are clear, you're tackling distinct problems. Whether that's around your transmission queues or utilization or affordability, whatever it might be. Just making sure it's super sharp to help speed up the understanding, the sales cycle, etc. I think all of that together kind of puts us at a time where hopefully, we're turning the corner, and a lot of these solutions will start to be adopted because, they really are becoming necessary. And hoping to see a lot of innovation get adopted and scaled over the next few years.
Fantastic. Thank you. Maybe Eran, some thoughts from you.
Yeah, I think that maybe I would touch another point that we spoke about scale, because we understand that there are right now big issues regarding capacity and resiliency, and there should be a scalable solution for you, for the customers. But I think we can look at scale in another dimension, which is, many utilities are facing similar problems globally. So when you build a solution, you need to think about the fact that when you start to deploy with multiple customers in scale on each one of them, you would have a massive installation of data. How you can build a solution that eventually each one of your customer would enjoy with the access to this huge amount of data, not just scale in which each one of the big customers that you may have, but rather about a global deployment, because resiliency and capacity challenges are not very different between the US, Europe, Latin America, and globally. And we need to look at scale also in this dimension.
Yeah, well, great point. Excellent. Manuel.
Okay. Can you hear me? Yeah.
Yes.
Yeah. Okay. I think that we will see the transition from a passive system and a quite analog network to a much more interactive and virtualization of the systems and substations and lines, and having this capacity of digitizing very fast with multiple technologies. To have this happening, we need to probably see some acceleration in the way that utilities, regulators, and technology firms, they can collaborate and talk. It seems that problem is a little bit lost in the table, no one wants to touch. Everyone says is necessary, but then no one is really taking decisions, and the decisions will come after major incidents that will happen, I'm sure, and this will be the most unfortunately will be the fastest way to make changes. And last, I see that we are talking about a huge, let's say, market number. I was checking in internet, and they say about near 700 billion over the next 6 years for grid digitalization. Means this is so big, and we need so much. Not only for the integration of renewables because they are stopped, data centers, they are getting also some problems to integrate, electrical vehicles the same. If we really want to create the foundations for the renewable integration, the rapid decarbonization and having a future energy innovation ecosystem, this must happen very soon. That's all from my side. Thanks.
Yeah, excellent. Rahul.
Yeah, so I see, so this whole notion of speed and pulling things faster, it has to happen we'll have to move to a national view of the grids as opposed to local utility level or RTO or ISO level view, because that's the only way the adoptions will take place faster. Both on, I mean, I'll give you an example. Right now, we talk about this pilot hell, and you go to every utility and you have to run a pilot, and then you have to run another pilot, another one. If you go back to another industry which is just as critical and it has human lives dependent on it, the healthcare industry, you see how the FDA actually went in and did the 501(k) approval process. Now you have all the class 1, class 2, class 3 solutions, and once approved, you can use them everywhere. So that's the kind of change we would need to see in how we approach things. It has to be at a level where these are national decisions, not a utility decision I mean, utility can choose to adopt that technology or not, but the approval should not be every single 30, 50, 40 times, So that's the one piece. And the other piece also at the national level, we are having the same thing. We kind of pretend like all our grid is not interconnected. Everybody's doing their own thing. And so the planning is also that way. We kind of plan at the utility level and the ISO level. And I kind of feel like there should be a national integrated grid planning commission sort of thing where that should inform all the other planning processes. So both on the planning side and on the implementation side, we need some more national involvement as opposed to individual corporations and companies and ISOs doing their own little thing. I mean, that's the only way to accelerate data. Otherwise, what will happen is we'll just always be in this very slow moving process while the problem is going parabolic and we're moving linearly. So that has to change.
I think you're so right, Rahul, and it kind of points back to something I was saying earlier, that energy is becoming strategic. We see how the US is using that as a leverage tool, for AI or for influence in Europe. I mean, a lot of gas now comes from the US, and it is directly correlated to GDP growth. The more energy you have, the cheaper it is. But I think it's exciting times for this industry. We see some big investments coming into some utilities. I think they're going to become, rather than passive companies, they're going to be quite active. It's exciting times. And as you electrify everything, they will naturally, by their nature, become center stage. So this, I think, is, resiliency is kind of the base of it. And I think, Eran, as you talked about, just capacity, but there's also, frequency and voltage regulate, all those things that people take for granted that keep this world sort of scotch taped together. We got to sort of triple it in size in the meantime. But this has been really, really enjoying for us, and I hope for our audience. So I wanted to thank you all for a really interesting discussion. Thank you.
Yeah.
Thank you.
Thank you.